This number 1 here has no effect on the problem because all we're trying to get from this equation is the slope. Once we get the slope from this line, we can then use it here because, again, we're trying to find a line L, we'll call it, where L is perpendicular to M through the point P. That's literally what we're doing. We're finding some other line that's perpendicular to M through the point P. So if you want to solve this 1 in M, you can, but you could also recognize that when you move the 1 over, it doesn't do anything. It becomes 2x minus 1 equals 3y, and then this is 2/3 x minus 1/3 equals y. So my slope can be extracted right here. That's the slope of the line M, 2/3. But I want a line perpendicular to that. I want another line, right, perpendicular to line M, whose slope is 2/3. So what slope should I use? Negative. There you go. Negative 3/2. So our slope that we're going to use for line L, and I'm going to write y equals mx plus b, becomes the following. Y equals negative 3/2 x plus b. And notice, what did I use? I used slope-intercept here. Doesn't matter. If it doesn't ask you to specify what type, it doesn't matter which way you go. All that matters is that your slope is correct, because these have to be perpendicular to each other, and therefore the slopes are negative reciprocals. What's the one? Yeah.
So you put the denominator, switch the denominator and numerator, and make it a numerator negative.
Correct. So when you think of the word negative reciprocal, negative means tack on a negative, reciprocal means flip it. Okay? The word, just so you're aware of the vocabulary I'm using. So when I say negative reciprocal, I do exactly that. Switch the top and bottom and negate the entire fraction. If the fraction were negative to start, you then make it positive, right? Negative is positive.
Can you also do it in point and slope form?
Yeah, absolutely. 100%. 100% you can do it. You'll get the same answer. It might look different, but it's the same line. So if you want to use point slope might actually be easier because you have a point and you have the slope. I happen to like point slope, but I notice a lot of you like slope intercept. That's honestly the reason I went to this. Most students in this room jumped in this form right away. And it's because it's taught in middle school as like the one form of a line when there's others. So point slope is absolutely acceptable to utilize.
I didn't change the form at all, so my answer came out to negative 1/2 x equals 3y plus 20. Would that also be correct?
Does the slope come out to be negative 3/2 when you do that? Check it all to work. Depends on what you get there, Sean. Take a look at what your slope is of your line. It should be negative 3/2. And see if the 0.27 or 2-7 fits your line. That's how you can check. Again, it's 6 1/2 dozen. I've said that before. Right? Depending on which way you choose, you'll get to a different answer, but the answer is the same. God bless. So now, in this line, what I'm going to do is I'm going to apply the point 2-7. So -7 goes in for y. This is the y value that goes in right here. 2 goes in for x. That's over there. So I've got -7 equals negative 3/2 times x, which is 2, plus b. And then I solve for b. So one method is to use slope-intercept and solve for the unknown y-intercept for the new line, and then write the answer. Well, these cancel, which is nice, right? Agreed? Everybody sees that? I take the 3, move it over by adding it. This becomes -4. So b is -4. And therefore, my answer for this one is y equals negative 3/2 x minus 4. Now, Sean, you could tell me if your answer is right based on manipulating it to this form.
No, I missed
So that means there's something. See what I mean? How you can check? Okay. So this is the answer in slope-intercept. Neighbor, what'd you get?
That's what I got.
What'd you get in point slope when you had it, though? You left
I
it?
got
Or you rearranged it?
y plus 7 equals negative 3/2 times x minus 2. And then from there, y plus 7 equals negative 3/2 x plus 3. And then y plus 4 equals negative 3/2. And then y equals negative 3/2 minus 4.
So I'm going to put that dash line. Eventually, right? A couple steps later, we got to that same point. So what we're noticing here, is that we have two different types of ways to solve this. One, with slope-intercept. One, with point slope. But both of them would lead to this answer if we put our final answer in slope-intercept. Again, you could also use standard form. But students don't seem to like standard form as much. I mean, that's fine. You don't need it. But I will tell you, on the test, if I give you something in standard form, it's very easy to find the slope by just doing negative a over b, much quicker than solving for y and finding the slope. But either way is acceptable. Either way is acceptable. If you're given a line, I shouldn't say curve, but if you're given a line in standard form, you should absolutely graph it by the intercept method. It's the fastest way, right? For graphing lines, like there's two ways to graph lines. Let's take a look at an example of that real quick. I know there's other questions I'm going to get. There are two ways of graphing lines, really. First, you can use intercept method. And second, you could use the slope and a point on the line. Either way is fine. So, if I'm doing this, I might say, okay, if the equation is given as 3x plus 2y equals 9, and another time the equation was written as y equals 1/2 x plus 7, well, it makes sense for the first ones to graph by intercepts, because the intercepts are very easy to find. The x-intercept is 3. How do I do that? Well, I set y equal to 0, so that drops off. X turns out to be 3. Then if I want the y-intercept, I set x to 0, and the y-intercept is 4.5. So my intercepts are going to be 3, 0, and 0, 4.5. I would graph those two dots in red, 3, 0, 0, 4.5, and literally connect the dots. Here's my graph for the first one. If it's in slope, if it's in point slope or slope intercept, I would use a point and then count up with my slope. Literally just count. What point would I use if it's in this form? What's the coordinate that I know exists on this line already?
0, 7.
0, 7. 7 is the y-intercept, so I would definitely use 0, 7. And I would also say, well, the slope is just 1/2. Let me make believe this is blue. So it would look like this. Here's 0, 7. You go up 1, go over 2. Put another point. Up 1, over 2. Another point. And we can do this a couple times before we get a line. So if you're given something where it has the slope explicitly and the y-intercept, or if it's in point slope, you can do that as well. You give it a point, you give it a slope. I would do it this way. If it's in standard form, you're definitely going to do it this way. And I'll give you a hint. I will tell you now that you will definitely have both of these on your test. Graphing by starting with a point and using your slope. Graphing by finding your two intercepts and connecting the dots. You absolutely have to be able to do both of these ways for graphing. Okay? And they're really the same. One of them involves a point and a slope. The other involves 2 points. But in both cases, it involves 2 things. So you need 2 things always.
But on this test, would you get us graph paper, or do you just want to?
You'll be given graph paper. Yeah, it'll be a grid on the test with an XY axis, or just a grid with empty boxes, or with no XY axis, and then you figure out where the XY axis goes. Okay. So what are the 2 things we need to define a line? Either 2 points, or what is it?
A y-intercept and slope, or a point.
Good. A point and a slope. Again, we need 2 points or a point and a slope. If we have either of those options, we can easily draw / define any line. Any line. All right. Sorry, there were other questions after Gus, Jimmy, and then Nick. Go ahead.
Mine is 3, so I was getting back up to it. 3 is number 12.
If you have it, that'd be great. I don't have my textbook.
So it's on the slope, but it was from points. It was A, comma B, negative B, negative A, and then A is not equal to negative B.
So those are the 2 coordinates given?
Yeah.
Okay.
And they had A is not equal to negative
Yeah, so a problem like this looks confusing because it's not numbers. But let's ask Clark to help us. What's our definition of slope here? What are we really doing?
Changing y or we change.
Very good. Go ahead, Clark, keep going.
So you could do like negative a minus a, or I mean, sorry, negative a minus b.
So that's the change in y. See the order he's subtracting? It's important that we subtract in the same order. It doesn't matter what that order is as long as we are consistent. So Clark is choosing negative a minus b for the numerator. If you decided to do b minus negative a, that's fine, but then you need to subtract the x coordinates in the same direction. Yeah? We see that?
Yeah.
Okay. Go ahead, Clark. So you have negative a minus b.
Negative a minus b, and then negative b minus a.
Negative b minus a. Okay.
And you can just change that to make it positive.
So what do you mean? You can just change it.
Since they're all negative, you can multiply it by a negative, and they would all be positive.
So multiply everything by -1,
Yeah.
right? Yeah, so what Clark is saying is, hey, let's factor out our -1 here. Let's factor out our -1 here. Well, -1 over -1, what happens? Those cancel, right?
Yeah.
So what am I left with?
A plus B over B plus C.
Which is really
Slope equals
1. Okay? So this is the kind of problem you could expect on this test where things are given variables. Maybe the letter K is used somewhere, right? And you had a couple of those in your homework, but it's the letter K. And then you have to simplify. By taking out the -1 out of both these terms and both these terms, those cancel, and A plus B over B plus A is the exact same thing, right? Commutative law of addition. So these must be the same. A number divided by itself is always equal to 1. I'll take it. That answer your question? How about this one as a follow-up before I get to the next question? As a follow-up. Determine the value of K so that the line connecting these two coordinates has a slope of 3. Determine the value of K so that the line connecting these two coordinates has a slope of 3. And if you're confused, think about what slope means right away. Slope means change in y over change in x. So we know already that the change in y over change in x is going to equal 3. Right? It's going to equal 3. We're told that the slope of this line connecting these 2 points is 3. So we literally apply the exact same thing that Clark just told us. Take y2, which is 7, minus y1, which is k plus 5. So I have 7 minus the quantity k plus 5 over k minus 3 minus number 2 here equals a slope of 3. So I've literally written my definition of slope, y2 minus y1 over x2 minus x1. And since we're told that the slope equals 3, we set this fraction equal to 3. Collect like terms, make things pretty. 7 minus 5 on the top is going to be 2. I'm going to also have a negative k, so negative k plus 2 up top. In the bottom, we've got here k minus 3 minus 2, or k minus 5. That whole thing equals 3. What's my next step? Because this is where students seem to struggle on tests or make mistakes. What's my next step? What do I do? What do I do here, Julian?
Do you separate k over -5 into over k?
What do you mean by separate? What does that mean?
You have a numerator of negative k over -5, and added to that you have a numerator of 2 over a denominator of k.
Can't do that one, no. Because remember, when you add fractions, they have to have a common denominator, right? So we can't split it up with different denominators there. But I can do something still. I can still do something else. Nick?
Multiply each side by k minus 5.
How come?
Because that gets rid of, it puts k on both sides and it's easier.
See how this is in the denominator here? It's currently being divided into this. So we can multiply by k minus 5 here, multiply by k minus 5 here. These k minus 5s cancel. And it puts k all in the numerator. What is this really an example of?
Cross multiplication.
Yeah, it's a proportion. What's 3 really over, everybody? What is 3 over? It's over 1. So go ahead and write it this way, please. Maybe that'll help, because on the test, if you have a fraction that's 2/3, what are you going to do? Well, you're going to cross multiply, as Sean said. Cross multiplication is allowed. We're allowed to move things diagonally and cross multiply. The product of the means equals the extremes always. So 1 times negative k plus 2 is simply that. And then 3 times k minus 5. This is what it becomes when we cross multiply, which inherently is what Nick said, really, right? Nick said, you know what, just multiply by k minus 5, and that's exactly it. And then we solve. We move the k over to make it a 4k on the right side. Move the 15 over, makes it a 17. And there's k. Please, 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 do not think, oh, it's a fraction, that can't be right. Nowhere does it say that k has to be an integer, anywhere, right? Just because a fraction has no problem with this at all. It does not have to be listed as an integer. Okay. Charlie, you had a question?
Yes. It was the last problem of problem set, which is 18 on 3/6.
This is 18 in section 3.6. Do you happen to have it written down?
I have it.
Oh, it's a word problem.
Yeah.
Okay. Oh, yeah, this is a messy one, right? Revenue, cost, the whole thing? Okay, cool. I like it. So it says in a certain mill, the cost C is given by 0.3x plus 3.5, and this is the cost in thousands. And this is for producing X tons. That's what's happening. X tons of steel. Is it steel? Yeah, it is steel. Okay. And then the revenue function for this, in thousands again, for producing X tons, is 0.5x. First, it says graph each equation. This is great. I love this one. And then it says find the point at which it's break even. And then it says, what does the difference between R minus C actually mean after the break even point? So let's take a look at this graph. Clark, you want to help us start? Yeah.
Yeah. So what it put it into is pretty much two point slope intercept
Good.
forms. So you just graph this out, and you start with the y-intercept for each of them. So 3.5 and then 0 for.
I'm going to go by 5s because I think I'm going to go higher later. So let's start with 3.5 is approximately here. Agreed? And 3.5 as a slope of 0.3. So I go up 3 over 10. Up 3 over 10, right? We all see what I'm saying by that? When you see a decimal as a slope, it is very useful to convert that decimal into a fraction. It makes life easier. So I'm reading the cost function right now in my mind as this. So I'm going to go up 3, which means I go up from 3.5 up 3, brings me to 6.5. And then I'm going over 10. So let me put 10 right here so that I have a little bit of room. And again, I might run out of room, so I might have to make this graph larger later. Now, by the way, if you have a question like this, you'll definitely be able to use your calculator. Because I'm going to want you to find the intersection on the calculator. I'm going to want you to discuss the meaning of that stuff. So this is a great example, but you'd be able to use your calculator for it in this case. Now, you're going up 3 over 10, which makes the next point over here, right there. So here's my cost function. Why am I not extending this line to the left? Why am I not extending it?
Because you can't have negative cost.
Careful. Can't have negative, what does X represent?
Oh, the tons. You can't have negative tons.
Can't have X as a negative amount for tons of steel. So I don't go into the negative for the X. For the Y is the cost. The second function, which is the revenue function.
Yeah, it starts at the origin because you start with no revenue.
Very good. And the slope is?
It's 1/2.
Yeah, 5/10, 1/2, right? So I go up 5 over 10. I'm right there. Up 5 over 10. Now, based on my graph, it looks like the break-even point is going to be there. It might not be true, by the way. I'm drawing a sketch right now, okay? To make sure we're clear on this. What does the break-even point become?
If I remember, it was like 17 and like 8.5. So it was something weird like
I know it's
2.5.
17.5 and 8.7.
Perfect, actually. That kind of looks actually like it's pretty correct, right? Or close to it. Let me just make this guy look a little bit better. Now, I'm going to make it look like it separates there, okay? All right. So the break-even point in any economic application, which we've talked a little bit about already, like profit is the amount of money you bring in minus the amount of money you spend. So profit is your revenue minus your cost. The revenue minus your cost. In the beginning, what's more, the cost or the revenue? In the beginning, before it reaches the break-even point, which function is the higher of the two functions? Just look at it. Which one is the function that's above the other? This is the what function? Cost. It costs more initially. This is for all things, by the way. If you're going to one day invent something and manufacture it, you're going to have startup costs. The cost always supersedes the revenue to start. You're always in the red? What's the phrase for that? You're always in the negative. You're always in a deficit to start. This is your deficit right here. Literally. $3,500 is your deficit. Because your cost is already at $3,500. Your revenue is at 0. What's happening to the distance between these lines, though? So it's closing the gap. Have you heard that phrase before? Closing the gap. It doesn't always apply to economics, but it does here. The gap is our gap between cost and revenue. Eventually, when there's no gap there, what does it mean? When there's no gap at all, Sean?
The revenue exceeds the production, no startup cost.
What exactly here not exceeds is
Equal to.
Equal to, very good. Now beyond the break-even point, assuming both functions continue in a linear fashion, not the case, by the way. Real life is not all linear. We're learning models of linear functions because they're easy right now. But in real life, your functions change as you produce more. Certain manufacturing processes have certain what are called thresholds. Like, yeah, you might want to produce 10,000 shoes, but after the first 2,000, it's not worthwhile to go further because then you have to pay overtime for your workers. So certain things come into play that make this a nonlinear function. For the sake of this course, they're linear. It's nice. It's easy, right? So after the break-even point, we notice our revenue is now above our cost every time. The revenue is above the cost. The revenue is above the cost. So if I were to subtract the revenue function, the cost function from the revenue, what it would give me would be this gap. Like the revenue function is this, that height, while the cost function is this at the same moment in time. See those two lines there? The difference between the black and the green line drawn there at around 22 tons of steel produced, that difference, this little missing piece right here, is your profit. So part C, when it says, hey, what is the gap between revenue and cost? By definition, that's what profit is. So if you took the upper function again, revenue, and subtracted cost, that is profit. And that is, in this case, let me use yellow. Well, actually, yellow is not going to work too nicely here. I guess I'll use a white line instead. Is this white line right here. Okay? You can barely see it, but that white line right there is your profit. The distance between revenue and cost as it continues to expand means what's happening to your profit. Over time, your profit is doing what?
Getting bigger.
Getting larger. The gap between the revenue and the cost keeps getting bigger and bigger. Why do you think it's called a profit
Margin.
It's the margin, thickness. The distance between two lines is the margin. The margin on your page is where your text ends and where the page ends. This is called the profit margin there. Okay, good question to ask. If you have a question that you're looking for the intersection of two functions, we can do it algebraically by setting them equal and find the intersection, or graphically. You should have practiced how to do it on your calculator by now. If you haven't, it's definitely something you want to do on the test, especially if you have an intersection that's not an integer value. The intersection might be like 2.87 comma 4.13. Who knows what it is, right? So you have to be able to use your calculator to do that as well. Where's that video? Moodle. Yeah, on Moodle under videos from class and other video resources. And it says, or other resources. I put a lot of extra stuff. It's not a video I recorded. It's right off YouTube. I literally found a good video for it and said, hey, you guys can watch this in 3 minutes and learn how to do it in your calculator. But if you forget on the test, hypothetically, and I say solve this by finding the intersection and graphing it, and if you have trouble, what you could do is you could say, well, when does the cost equal the revenue? That's the break-even point right there, when they're equal to each other. So just set the functions equal and solve. That works as well. So 0.3x plus 3.5 is equal to the revenue, which is 0.5x. And if you solve that equation right here, you should get approximately 17 and change, which is where our break-even point occurred. And you're getting x, which is giving you the amount of tons of steel. That'll give us the break-even point. And then once we know x is around 17 and change, we can plug that in here to get the cost, or plug it in here to get the revenue, but they're going to be equal to each other. They're going to be equal. John, question.
How much was this problem worth in the problem set?
I have no idea. Probably like 1 or 2 points is my guess. It's usually based on every answer you give for the problem. So if the problem is one or two parts, it's worth 1 or 2 points. It really just depends on which one.
How much would you be losing on a test?
On a test, this is probably like 3 or 4 points, but out of a test that's worth 50 points, that becomes 6 to 8 points, really, if you think about it percentage-wise. Right? You picked up on that by now, right? Your tests are at 50 points. So even though it says in the test 2 points for a problem, it's really worth 4, because it's out of 100 when you do percentile grades.
Could you update the problem set answer?
I can. You want it right now? I don't have the document made. I gotta make that document. It'll take me like 10 minutes and I can't do it right now. Can I do it at the end of the period and I'll upload it? Yeah, sorry about that, Lola. Thank you.
I was wondering if you already have it.
I do. I just have to like combine the PDFs of each section. I have all the section answers separately. So I have to put 3.1 and 3.6 as one PDF. I have to do that on my computer. So, Jimmy.
Are you laughing?
Yeah, you go.
Can we go over one of the problems?
Yep. What do you got?
For 3.19, and it's Not n is odd and exceeds k by more than 18. I just don't agree.
Say again. N is odd.
And exceeds k by more than
We didn't have this problem.
18. No, I know about it.
That's fine. Exceeds k by more than 18. And what does the instruction say? Or what do the instructions say?
It just says an exercise.
Oh, this is the two-digit numbers. Okay. So this is the question that says the digits of a positive two-digit number are given as n and k. Find the possibilities for n under the conditions described. So this digit is literally this. Okay? Now, we're then told that the number becomes this. All right, we're going to switch the two values there. And we're told in this problem that n is odd and exceeds k by more than 18.
Sorry.
Let's see the wording again.
I think n's like the full.
N's got to be the full digit, not the actual thing, right? This doesn't make sense. So the digits of a positive two-digit n, okay, become k. That's what it is. All right. So n is one number and k is the other. Each of those are comprised of two different digits. So we'll call letter n or number n AB, and we'll call k BA. That's what we're saying here, okay? Now, in this problem, we're noticing that these values are switched. So what's happening is my value, my tens and my units are going to switch. We talked about this concept already, that what is A and B worth? A is worth tens of A's, right? So when I think about this number, if this number were 31, it's really 30 plus 1. Right? The number 31 is really 30 plus 1. So this is really the number 10A plus B. So if A were 3, which it is, we take 10 times 3 gives me 30. And then 1 times B gives me 1, and I add them together. The second number, because it's written backwards, is 10B plus A. Now, the key is to recognize the statement in the beginning. N is odd. So right away, that means that B has to be odd. Agreed? Okay, so B has to be odd. We can jot that down in the corner if we want to, because that'll limit the number of answers we have. Okay, B has to be odd. And it says that n is odd and exceeds k by more than 18. By more than 18. So n exceeds k by more than 18. How am I going to write that? Equation, inequality. What are you thinking if I think exceeds by more than 18? It's in the same general hands. I'll tell you again. Get this one.
N is greater than k plus 18.
Again, if n were equal to 18 more than k, we would have an equal sign here. If it exceeds it by exactly 18, but if it exceeds it by more than 18. So n is more than k by 18, but by even more than that value is what it's saying here. All right, so now we can go ahead and plug in for n and k. And what's the key to this problem? The key is to recognize there are many answers. This was from section 3.1. So you might be confused because we've recently done section 3.4, 3.5, 3.6, where we solve a system. So you're probably wondering, where's the second equation I need to solve a system? It's not a system. So let's move our old stuff together. Let's move 10b over and move a over. This will become 9a when I subtract a from both sides. All right, subtract a. And then I'll subtract 10b from both sides. This will become 9a minus 9b is greater than 18. At this point in time, we have 9a minus 9b greater than 18. Divide everything by 9. It's logical to do that to make life easier on us. So the gap between a and b has to be more than 2. So what numbers work is the question. And a can only be a single digit. Remember, a and b are individual digits. They're not two-digit numbers. So for a, or for b, you could try 1, 3, 5, 7, 9 for b. Because we were told earlier that since n was an odd number, and since b is in the units place, the units place has to be odd. So you make a table at this point and see what numbers work.
Oh, okay. I'm sorry about
It's a good question though, right? This is one that we, I think as a class, had a little bit of trouble with. We had the notes with that one day, and then I had you guys do a homework example out of this. So if I think about these as values, if b is equal to 1, what can a be? If b is 1, what can a be, so that when you subtract them, you just get something greater than 2? There's a lot of options, not just one answer. I'll tell you, go ahead. 4 works, because 4 minus 1 is 3. What else works after 4?
Every number from 3 up to 9.
Does 3 work?
3? No, 3 doesn't.
Yeah, so from 4 up to 9, right? So there, right there alone are a bunch of answers. And try it, right? Plug in the 4. 4 minus 1 is 3. 3 is greater than 2. That works. But if I try 3, I get 2 is greater than 2, which is not true, right? So that's my possibilities for the 1. How about for the 3? If b is 3 now, put a 3 in here, please. In your mind, put a 3 here. And think about what numbers can go in place here and be greater than 2 as a gap still. Andrew.
6, 7, 8, 9.
6, 7, 8, 9. And try it, right? 6 minus 3 is 3, that's greater than 2. 7 minus 3 is 4, that's greater than 2. 8 minus 3 is 5, that's greater than 2. So the goal was to really get to this line here. Notice that? The rest of the problem actually doesn't matter. All the stuff we did is fine. This is what matters right here. Yeah, that one statement. Sean?
5 would be any number greater than 7.
Would 7, yeah, greater than 7. Good, so it's 8 and 9 only, right? 7 does not work. And then finally, how about the last piece? Is there a number that works? For the 7, there's not. Try it. Right? The largest one-digit number is 9. The largest one-digit number that can go there is 9. 9 minus 7 is 2. 2 is not greater than 2. So my answers for all the possible values are the original number, which is AB, right here, the original number. So that's going to be 41, 51, 61, 71, 81, 91. Then 63, 73, 83, 93. Then 85, 89. What am I doing here? I'm doing something wrong. 6, 7, 7, 85, 95. Thank you. I was jumping up to 87. Okay, so we always go in the order of AB because this was written as AB here. This is 85. This is 95. This is 63. This is 73, 83, 93. And again, how do you check your answer? Take any of these 2-digit numbers, switch the order, and subtract those 2 values. It should be more than 18 as an answer. That's the whole premise of this problem. So take 91, switch its digits, become 19. 91 minus 19, is that more than 18? Absolutely. Just, you don't even know what the number is. Just think about it, right? 91 minus 19 has to be more than 18. It's not logical. So a tough kind of problem, but something that you could definitely be, it could be fair game. I'll tell you.
All of them work?
All of the ones that we listed on the right work. There are a lot of answers. All of these are possible solutions, yep. But notice that we didn't do numbers. I'll tell you, like 61. I'm sorry, like 61, we did 53, for example. 53 is odd, right? But it doesn't suffice. 53 minus 35 gives me what? Exactly. And what did it say? It should exceed by more than 18. So a number like 53 isn't in our answer because the difference between 53 and 35 is 18. But this is the algebraic approach. You literally take this for the first number and then switch it for the second number. Then you go to your statement that was coming from the problem up here. And that comes from this. And then what you can do is literally take this, plug it in here for n, take this, plug it in here for k. That's where it's all coming from. All right, other questions? Keep going. Is it good? What else are you wondering? We did an example of 2 graphing lines. We did an example of perpendicular. How does parallel change that problem? If it didn't say perpendicular earlier from the first problem we did, and instead it said parallel, what's the one difference that I have to consider when I'm doing a problem like this? There's one major difference. Clark, what's that major difference?
The slope.
The slope. So the slope of perpendicular lines are negative reciprocals. Remember that term, negative reciprocals. The slope of parallel lines, they are
The same.
the same. So if I wanted to find a line parallel to another, just find the slope of that line and use it for your new line. Again, parallel lines have the same slopes. How about a problem like this? You did a couple of these. In the equation, let's say the line L goes through P. If L is given as 2x equals 3y plus 1, and P is the coordinate, 2x, hold on, let me make a correction there. 2x equals k by there, times 1. And the point P is listed as 2, 7. Determine the value of B. If L goes through point P, and if L is equal to 2x equals by plus 1, and the point P is listed as 2, 7, determine the value of the coefficient B. First of all, if a line goes through a point, or if a point is on a line, those are the same things. What does that mean? Physically, what does that mean to us? Careful. If a point lies on a line, or if a line goes through that point, what can we say about that relationship that's happening?
The point that's on the line is the solution.
Correct. The point satisfies the equation. So what that means is, again, if this point is on the line, or if this line goes through this point, we can take x and y and plug them in the corresponding positions because it should hold true. Well, if that's the case, this equation becomes 2 times whatever the x coordinate was, which was 2, equals b times the y coordinate, which is 7, and then plus a 1 at the end. Remember, b does not have to mean y-intercept. I could use b as the coefficient for y, which I did clearly in this problem, right? We're solving for b, but b is not the y-intercept. B is an arbitrary value that we're trying to determine if the case is presented here that the line goes through the point, which it does. All right, so just solve for b. Subtract the 1, you get 3/7. Yeah? And if you're not sure if that makes sense, here's what you do. You take the 3/7, right? You plug it back in for b up there, plug the 3/7 in for b, and then plug the coordinate in for x and y and see that it actually is a true statement. And that's how you know it's right. Hey, after school today I have office hours, right? It's Wednesday. If you have more questions, you want to go over stuff individually that you struggled on with the problem set, you should absolutely be there today after school. Tomorrow I have robotics. I can't guarantee you'll have time after school. So today is the day to come with questions for your test. Tomorrow you're starting your presentations. All presentations are due in Drive. Again, I highly recommend you use a PDF. Even if you're in another program, just save it as, or export as, or download as a PDF. So tomorrow we have no issues with glitching along the way. Is that clear? Okay, get your project in. Even if you don't present tomorrow, you get your project in. You got it, anytime. I'll wait till tomorrow. good. Come after school today, still. Thank you. Thanks. And I'll see you tomorrow after school, yeah.